installment in our scientific computing webinar series. Today, we'll have once again Chris Dagdigian, one of the founders and senior technical director at BioTeam. Chris has been doing this for 20 years and has managed to kind of keep working his way down the org chart to stay an in the trenches consultant. And he's got some more content to share on ParallelCluster today. Just a few housekeeping notes for the webinar. Feel free to ask questions in the Q&A. I'll be in there looking at them, but we will hold questions till the end if you want to speak up and ask a question directly. Also, anyone who registered, you will get a link after the webinar, probably in a couple of weeks, with the webinar recording and the slides. So all this content will be shared with you through the email address that you registered with. And that's it. So yeah, feel free to ask questions in the chat. I'll be hanging out. Otherwise, take it away, Chris. And thanks everyone for joining today.
All right. Thanks a lot, Adam, for the introduction. And everybody, again, I'll reiterate, good morning, good afternoon, good evening. We really appreciate you taking the time and effort to sort of come out and listen to us today. This is a brand new deck for me. I'm a little bit worried about time. So if you've seen me speak really fast in the past, it's going to be just as fast this time around. I also wasn't sure the level of interest in this particular topic. And so I wanted to put a sort of quick summary at the top of the presentation so you can bail if this is going to bore you. So at the end of the day, what we're really talking about here is RStudio Workbench is a really popular platform. It's available in open source and commercial versions, but Posit, which they've rebranded from RStudio, has a nice commercial version of this that comes with some features that allow us to integrate this really interesting, it basically integrate RStudio and web notebooks and data science notebooks into auto-scaling ParallelCluster environments running on Amazon. So I think, when trying to figure out how to crack the nut to sort of seamlessly provision data science resources delivered to users in the form of a web notebook in a way that is auto-scaling, elastic, and doesn't waste money, what we found is that integrating Posit Workbench, which is the commercial name, using their Slurm integration launcher with AWS ParallelCluster is kind of a nice, low-key, high-value way of delivering web-based data science notebooks in a flexible and elastic way to end users. So we're going to cover the basic tips and tricks on this. We can go deeper and highly technical into future webinar events if there's interest, but basically just wanted to throw it out here. This is generally what we'll be covering today. So this is also part of an ongoing webinar series. We tend to talk a lot about ParallelCluster and scientific computing on the cloud. So, if you're interested in this topic in general, back in August, we did kind of a general, best practices, lessons learned on just AWS ParallelCluster operation. And then, we'd like to go niche and talk specifics. And a lot of our consulting work is around integrating commercially licensed scientific software into ParallelCluster environments. So we did a webinar on the Schrodinger CompChem suite and teaching ParallelCluster how to be license aware when it comes to job scheduling. So if there's any interest in that, the slides and video for those older webinars are definitely available, and they're available at the links up here. I will just do the very quick intro since Adam already talked about this. I think most of our friends are on this meeting and generally know who I am. Basically, I'm a former scientist turned infrastructure person. I've spent the last 20 years sort of supporting research computing in demanding commercial pharmaceutical and biotech environments. This is not a slick talk. This is not a marketing presentation. This is not even the consensus view of BioTeam. This is essentially a brain dump of some projects that I found myself repeatedly involved in over the last year. And I figured it might be nice to kind of put it down in writing and sort of give it out in a sort of public way. There are a lot of words in the slides because one of the things we found is that the PDFs of our webinars tend to get distributed all over the place. And so we'd like to make them word heavy because sometimes they become reference material for people. The PDFs live far longer than the recorded video, basically. There are a number of slides in this deck that is kind of an introduction to BioTeam and what we do. I'm putting them in there really just for the audience and people who find the slide deck down the road. I don't intend to cover, the BioTeam marketing pitch in this live version. So these slides are basically reference material for people to get the PDF and need a little bit more context on who we are and what we actually do. So we'll go a little bit quick through here and then sort of dive into the content. So one of the reasons why we do stuff like this, and again, it's not for a sales pitch, it's not for marketing. A lot of us at BioTeam are scientists, who came out of the scientific world, and a lot of us during our, early career, we benefited greatly from the open source community, from researchers and collaborators and software developers who are willing to share freely with us. And I know personally, as a sort of, founder and owner of BioTeam, my experience with the open source software movement when I was early career greatly influenced how I think about sharing knowledge and spreading the word. So, in generally, one of the reasons for this is that we like to talk in public about stuff that we like, and we like to talk in public about stuff that makes our consulting work and our scientific work easier. ParallelCluster and Posit Workbench are definitely two things that we like and make our jobs easier. And since we didn't write either of those products, the least we could do is sort of talk it up in public and try to do a little bit of evangelism for it. So the other thing is we can go additional topics as well. Some of the things that have been going on around this topic are, that we could have in future sessions involving, messing around with the Slurm RESTful API, lessons learned when trying to integrate, remote desktops and VDI environments into this environment. There's a lot of enthusiasm around things like Open on Demand and Open XDMOD. They do different things, but integrating them into this type of environment is interesting. And then finally, Slurm as a job scheduler actually has some relatively interesting multi-cluster, cluster of cluster, and sort of federation models. And, as there's more interest in sort of, sensible hybrid cloud patterns, co-location, public cloud patterns. If there's interest in sort of talking about Slurm multi-cluster and federation, definitely let us know. We're basically looking for feedback on other sort of topics that we can kind of queue up and sort of talk at you in public about. So with that said, I want to set the stage a little bit about RStudio. And again, I'm going to interchangeably use the term that, with the rebranding, it's Posit and it's Posit Workbench. If you're talking about the commercial version, they really want to sort of make a separation from open source and commercial. And so, but I'll probably mix up both speaking and in slides. So out of the box, Workbench is really powerful and it's really, consumable and usable. Chances are everybody on this webinar has seen it or is even running it in maybe a Docker container on their laptop. But the interesting thing here is when you start talking about data science and sort of data-intensive life science informatics, you start to think pretty seriously about the resources that are backing your scientific notebook system. And so just running Workbench on a single server is not necessarily the greatest thing if you have changing or dynamic or relatively exotic hardware needs. And then finally, when you get beyond monolithic servers, there's a design pattern that involves clusters, but those clusters might be identical and they're really sort of load balancing based on simple metrics and triggers. And again, you really don't quite get the sort of elasticity and flexibility that you're looking for. So this is kind of an example of the sort of single monolithic server. It's, one of the great things about Posit is the documentation is fantastic. The software is really easy to install. It's very, very easy to get this up and running on a single machine. Add in single sign-on and SAML. All of that stuff is really, really nice. However, you don't have a lot of diversity and resources that you can offer to your users, and you don't really have a way to scale up if your your Posit Workbench server starts becoming a lot more popular. And then finally, if you take a defensive hedge and you pack this monolithic server with tons of memory, tons of CPUs, and tons of GPUs, it's really expensive to run 24/7. So, we're looking for basically things that we could do beyond this pattern. If we take this pattern and we extend it out, Posit Workbench also has really good support for clustering. They've managed to sort of separate out session data and file logging in a database that can talk to multiple systems. What that means is you can horizontally scale and add more Posit Workbench servers. However, the servers are probably identical or mostly identical, and the load balancing is relatively simple. It's using session stickiness to kind of pin your web session to one particular node in the cluster, and your web session will only relocate if that node goes away or has any problems. So it's a really great solution for high availability and uptime. It's a really great solution if you need high availability and high uptime, and you have relatively static resource requirements. It would be dirt simple to bang out a cluster of these machines, tie them together with a load balance, put a couple of scaling rules around it based on CPU load or number of user sessions, call it a day, and you're done. But what we want is actually something a little bit more different. And so this is kind of the high level view, and I'm putting magic in here to sort of talk about what we wish we would have. What we would really like to have in this environment is we want users to be able to define the resources that their web notebooks and RStudio sessions run in. We want those resources in most cases to be dynamically provisioned, although there are cases where you have those machines standing by for sort of instant access and user feedback. And finally, we want Workbench to go out and deliver our user session to that new node or new resource that we just provisioned. And then finally, this stuff is expensive. We don't want to keep it running. So we really want sort of good garbage collection or scale down or clean up or however you want to sort of talk about it. So in this scenario here, I'm kind of showing you the sort of higher end use case. We've got user A hanging out on a node with 4 terabytes of RAM, user B hanging out on a multi-GPU node with 64 cores. And then finally, there's a bunch of users who maybe are just doing software development or running VS Code, and they just want an inexpensive but fairly fast and responsive machine to kind of run their notebook sessions on. When it comes to behavior that we want to see this environment change based on the dynamic requests of our users. So I showed you a bunch of expensive high scale resources in the previous slide. now say, a day has passed or a couple hours have passed, the heavyweight user jobs have ended, and now we've got multiple users hanging out on our inexpensive but performance, just let me run a notebook node. We continue on with our changing requirements. Now things have changed. We've got a little bit more users back on the system. They're not really using the exotic high scale systems, but we've got definitely multiple people who all want exclusive access to a node that has a GPU because they're doing ML or AI stuff or even CompCam or whatever else they want to be doing with this data, with this system. And then finally, the last thing we want, the last piece of magic that we want is we want this system to automatically clean up, automatically terminate, and scale down resources when they're no longer needed, when they're idle, or when a job is completed. This is really about making efficient and effective use of the cloud. It's about cost optimization, spend optimization. When you talk large memory, large CPU, and GPUs in particular, even with reserved instances and spot market and all the other tricks you can play to reduce your infrastructure costs on the cloud, it still boils down to the cost of compute is expensive when high scale hardware is involved, and definitely when GPUs are involved. So if you buy my pitch about this is the kind of magic sort of dynamic environment that we want, the one potential solution for this is, oddly enough, AWS ParallelCluster swaps really neatly into the magic box that I had showed you in the past couple of slides. And it's not rocket science. It's nothing complicated. At the end of the day, the reason why this is possible is because the Posit developers have developed launcher scripts for different cluster types. The two that they support is they can launch jobs into a Kubernetes cluster, which is interesting because then everything's containerized. Or from my view, and what makes this a really attractive solution for me in my world is they've got a launcher that knows how to talk to the Slurm job scheduler. Coincidentally enough, one of the job scheduling behaviors on ParallelCluster is Slurm. So that's kind of the magic here. At the end of the day, we're really just taking Posit Workbench running on a server. We're configuring the Slurm job launcher, and we're teaching it to submit our data science and web session jobs into an auto-scaling HPC compute node. And I'll talk a little bit about this pattern and why I like it and why it helps unify different types of science and computational resources, our researchers around it. This previous diagram was kind of hand wavy and high level. I wanted to show you a cheat sheet. This is not quite a Visio diagram, but this kind of represents my personal cheat sheet of the things that I sort of deploy. It's a little bit more realistic about resources. What you can see here is when licensing and resources allow, I like to complement Workbench at a minimum with Package Manager. I really would like to get connected in there if I have people doing Shiny apps or publishing data platforms. But at the end of the day, my sort of infrastructure mix, I've got Package Manager, I've got Workbench, I've got an AWS ParallelCluster. They're all sitting on top of a common shared file system. You can see there that I'm using FSx Lustre. And then finally underneath, you can see all of the other sort of what I call enabling infrastructure or enabling resources that you need to kind of run this. RStudio likes Postgres for session and metadata tracking. Slurm actually, or ParallelCluster actually uses MySQL for the job accounting database. You actually want databases for all of that stuff. And then finally, it's not really in scope for this webinar, but when I build these types of environments, not everybody can get their job done using SSH to the head node submitting Slurm jobs. Not everybody can get their work done pointing a web browser at Posit Workbench and launching a web session. There's a whole legion of data science and computational researchers who need graphical applications, and they want a performance Linux. They want a performant virtual desktop that sits virtually close to their data and their compute, is recognized by Slurm as a submit node. And so my diagram here, I've got No Machine. There's many different ways to solve this. AWS Workspace is No Machine. The cheapest and one that Amazon is going to push is Amazon has a really nice application delivery platform based on Nice DCV. It's actually the technology behind AppStream. And if you run EC2 on AWS, licensing for Nice DCV is free. And ParallelCluster actually ships out of the box with the ability to deliver a Linux remote desktop running off of the head node. So there are a number of different flavors of graphical computing or VDI delivery that are available in this mix as well. Again, it's sort of out of scope for this talk, but when I build systems like this, typically the next request that comes down the line is, I need to run ImageJ, or I need to run Schrodinger Maestro, or something that's sort of graphical that sits on top of this environment. So I'm going to do a little bit of diversion. Why ParallelCluster? Because like I said, this supports Kubernetes. This supports a couple of different options here. So, at the end of the day, I often find myself having to defend what some people will call legacy design patterns or traditional HPC on the cloud. And the reason why I'm not using serverless or InfiniDash or Batch or Kubernetes is ultimately because there's a lot of, I'm using the word lie in this slide, but at the end of the day, there's a lot of rosy marketing and sort of hidden embarrassing stuff when we talk about using the cloud. If you're talking to a cloud evangelist or a cloud salesperson, they like to pretend that all of our legacy workloads and all of our legacy, applications, they're just too embarrassing to discuss. They really want to push you to serverless and scale out and batch and spot market. And they really do think that all of our applications are going to be thrown away and we're going to happily jump into the cloud native world, rewrite everything from scratch. All of these rosy people believe that DevOps, infrastructure and code, and automated deployment is pervasive throughout our organization. Everybody knows how to do it. Everybody's got a team that's ready to deliver DevOps to them. And then finally, they also make the assumption in this cloud native rosy world when they're trying to sell you on cloud is they all sort of assume that everybody from the scientific end user all the way up to IT and research IT is really fully staffed and they're trained up and they understand cloud, they understand cloud features, they understand automation, and they understand how to support it. That is not a realistic view of what the state of data intensive scientific computing in the life sciences is in 2023. And it's not going to be cloud native and object storage native for a very, very long time. So that's really the reason. And actually, I've sort of talked over this, but at the end of the day, the reason why I build these legacy or these HPC environments in the cloud is that I know that I have hundreds, if not thousands of applications and Perl scripts and R scripts that will never be rewritten for a cloud native architecture platform. We also have a lot of tools, and some of the tools are quite expensive commercial software that only understand storage as POSIX storage. Like it really knows only how to consume storage that looks like files and folders. So again, we can't immediately jump to an S3 native future because we have so much of our legacy tooling and baggage that assumes a POSIX storage layer that can present data in the form of files and folders. And then finally, at the end of the day, scientists just want to get science done. They might have learned Python and R and Bash because they needed to get their science done. They don't necessarily need to know AWS batch or Kubernetes orchestration or things like that. At the end of the day, we want to sort of make the scientist as effective as they can, give them the tools so that she can be as successful as she wants. But at the end of the day, get out of her way and not force her to learn IT and not force her to learn cloud simply to get her research done in a different computing environment than what she might be used to using on premise. So again, if you buy that, why AWS ParallelCluster? One of the reasons why I fell in love with ParallelCluster is that it really truly does replicate the legacy HPC environments that I spent a lot of time designing and building in people's data centers. You get compute nodes, you get shared storage, you get the batch job scheduler, you get all of the stuff that I knew as an IT person. And from a scientific perspective, early career, mid-career researchers who've come out of academia and they come out of supercomputing centers, they are also familiar with Linux clusters and the Slurm scheduler or maybe Grid Engine, depending on era and when they came out of school. So this is a really nice leap to go from premise computing into the cloud. It recreates exactly what I'm already familiar with, and more importantly, a lot of my scripts and workflow and tooling will simply just migrate over to the cloud as well. But on top of that, ParallelCluster does far more than just replicate my premise-based HPC cluster. It also has all of the cloud magic. And by cloud magic to me is auto-scaling. Cloud magic is the ability to tear down the cluster and rebuild it with a different hardware mix if my business requirements change. It's the ability to deliver multiple clusters to individual teams of people because I'm dynamically composing my infrastructure and spinning it up on the fly. One of the biggest paradigm shifts is in the premise-based HPC world, we spend a significant amount of effort configuring and tuning our job scheduler to support multiple competing users, workflows, and pipelines. The big paradigm shift when you go to scientific computing on the cloud using Slurm and HPC is you don't need to have a monolithic cluster that's shared by many people. There are business and user and uptake and adoption reasons why having a really cool shared environment that everybody's happily banging away on is really good. But at the end of the day, if you need to deliver a cluster to the cryo-EM person and another differently flavored cluster to the structural biologist or the comp chem person and a completely different environment to the people who are doing genomics and bioinformatics, that's the sort of beauty and agility and utility of the cloud. The fact that everything's an API, everything's virtual, you can tear stuff down, you could rebuild it, you can sort of change on the fly. So really for me, ParallelCluster really does hit a sweet spot. It gives me the legacy patterns that I need to shift a ton of work and workload straight into the cloud, but it wraps it in a lot of the cloud magic, which for me, like I said, is auto scaling, agility, and the ability to spin up many clusters and present them to different business users if I needed to. So tying it back to Posit and ParallelCluster, in my scientific computing work, it's very common for me to go into a cloud environment and ParallelCluster is already there, or there's a business need to do it because the chemist just got hired and she needs Schrodinger to run at scale. So if I've already got ParallelCluster, chances are I already have a performant POSIX storage layer. I probably already have a way of resolving identity and password authentication. I've probably also got a centrally managed set of scientific software. If I've got all of that stuff already sitting in my scientific computing environment, it's really just a beautiful value add to add Posit Workbench into the environment. And now, instead of delivering VDI and command line based access to Slurm, I now can deliver a really nice, really scalable method of delivering VS Code and data science notebooks directly to the end users, all sitting on top of the common infrastructure. My storage is the same. My versions of R and Python are the same. My Conda environments are the same. My view of identity and UID and GIDs is the same. It's just adding Workbench into ParallelCluster, especially if you've already got HPC users using the traditional ParallelCluster bits. To me, it's just a no-brainer and it's an easy win. It it delivers an additional capability, a significant additional capability that users who may not, there's a lot of scientific users who want to consume compute, but they're not programmers. They're not comfortable with Slurm. They might not even know Linux at the command line all that well, so they really don't want to SSH into a compute node and run srun or submit batch jobs. So this is just kind of a really nice way to deliver a new set of capabilities to potentially a wider audience within your organization or within your company. So that's kind of setting the stage for sort of why this combination to me is really attractive and why I'm really interested in sort of evangelizing it and talking about it in public. So I'm going to take a little break, pause for reflection, and really just say one of the things I don't want you to take away from this webinar is that Posit Workbench plus ParallelCluster is the only way to deliver scalable data science notebooks to end users. I like to be honest. I like to be blunt in my talks. I have never seen a customer environment that just has one way to run a Jupyter notebook or just one way to run an RStudio environment. What you're probably going to encounter, and maybe those of you on the call are experiencing the same thing, is that this capability is part of a larger landscape, and the overlap is not necessarily a bad thing. For me, the sweet spot with Posit and ParallelCluster is really supporting data science teams and individuals who program in R and Python. If you don't have that legacy HPC requirement, if you don't have a need for Slurm, or maybe internally you don't really, you can't sort of resource or get your head around supporting Slurm, you could probably go straight to doing this on a Kubernetes launcher. You go straight into Kubernetes, bypass the sort of legacy HPC style that I still need because of my work and my customers. But finally, again, being blunt and honest, if you're charging into the ML and AI and sort of ML ops type space, you're probably looking for features and capabilities that you don't quite get perfectly solved with Posit and with with ParallelCluster, model training, versioning, things like that. So you're probably also looking at other commercial platforms that are in the space. There's a huge amount of innovation going on in the space. There's tons of different companies that want to sell you a different way to do ML AI or ML ops at scale. The ones I like, the ones I see, is I'm kind of a Saturn Cloud fan, and then I'm kind of a Domino Data Labs fan as well. Both of those have sort of solved interesting problems within my customer environments. But again, the take-home message of this slide is that this is not the single solution. You will almost certainly have to deliver web-based data science notebooks to consumers in your organization via multiple different ways. And you're going to have to let your business end users and your scientific end users sort of figure out how they consume compute and where they go for compute. Sometimes it's based on where their data lives. Sometimes it's based on who they sit next to and who they talk to. But you have to sort of satisfy that the need for sort of multiple consumers of these types of products. So the other thing I'm going to do, and I'm actually going to go quite quick through this, is I don't want to do a live demo, but I wanted to show pictures of the environment. So for people who kind of want to get a sense of what they might be getting into if they deploy something like this. So this is the first entry point. This is a ParallelCluster after logging in. If you know Slurm or you know HPC, what you can see here is a bunch of partitions. One of the reasons why I'm showing this picture is for consistency. You'll see these partitions show up in all of my slides, even when we start doing data science notebooks. So you can see here I've got default, I've got CPU queue, I've got multi-GPU partitions, I've got large memory partitions, all the standard stuff you can see here. If you know ParallelCluster, you can see that all of these are dynamically There's no dedicated servers in this cluster. They all scale in only when they need. That's probably not a realistic design in real world. You'd probably have a couple of nodes sitting available 24/7, so you can instantly satisfy a request for an interactive job. But this is kind of the environment that I built this slide deck off of. Also, same thing, if you know Slurm, Slurm actually sees the RStudio and the data science notebook sessions. They are literally treated as Slurm jobs. So these are RStudio sessions that are running on compute nodes, and via Slurm commands, you can see them and you can interact with them. You could kill them if you wanted to. I wouldn't recommend it, but yeah, you have all of the sort of capabilities at your hand here. This is, again, just a screenshot. And for those of you who are looking at the local host and the messy and trusted side here, this is built out in a disconnected VPC. I'm not cheating by running a Docker container. I'm actually tunneling traffic over AWS SSM to get into a disconnected environment. So all of my screenshots are going to show ugly, untrusted SSL certificate stuff at the top. So this is kind of your entry point. You can see here I've got a bunch of sessions that are active or suspended. This is kind of where the magic begins when you press the new session button. Depending on how you configure Posit Workbench, you've got Jupyter Notebook, you've got Jupyter Lab, you've got RStudio Pro, you've got R Markdown, you've got Graph Notebooks, you've got VS Code. And VS Code is kind of an aha moment for me. I'm a huge VS Code person because I do a lot of CloudFormation and Terraform work, and the ability to have an IDE in this environment was kind of an aha moment for me. The other interesting thing when you do this integration is you start to see cluster and HPC stuff showing up in your new session launch. What you can see here is picking the resources that you need to be successful. You can refer to Posit Workbench profiles. You can define your CPUs. You can define your memory requests. But more importantly, if you remember that screenshot that I showed you a couple of minutes ago where I was showing Slurm partitions, the exact same Slurm partitions that are in the ParallelCluster environment are targets for you to run your web session node on in Posit Workbench. So if you need the 4 A10 GPUs, you would send your web session to the A10 multi-GPU queue. If you need large memory or very high level memory, you can send your jobs to those machines. And if RStudio allows you to do it, because RStudio has really cool controls over who can do what and what resources people can consume, if you're allowed to do it, it will spawn you into that node that has 4 terabytes of memory, or it will spawn you into that node that has multiple GPUs. And then finally, the other thing I like is the magic is, again, all of this infrastructure is provisioned dynamically behind the scenes. So Posit Workbench does a really good job of sort of tracking the lifecycle of the job. And when the job has migrated, transitioned, gotten itself bootstrapped, and is up and running on the compute node, it will automatically connect your session via like these proxy connections. And at the end of the day, you're delivered a notebook. That notebook is actually running as a Slurm job on a compute node. The compute node only lives as long as it's needed, and then it cleans up and goes away. So this is kind of, sort of the graph that's kind of showing you for me like the value and sort of agility coming out of a solution like this. Again, I want to show screenshots of each individual product. So this is just the VS Code IDE running as a Posit Workbench session. I brought up the terminal again, just to show you the Slurm partition is there. It's visible. Everything's unified. My data's here. My home directory is the same. All my tools are the same. My Slurm commands are there, and I can also type in an IDE. This is, again, just a boring screenshot of running a Jupyter Notebook interface. This is a boring screenshot of transitioning to Jupyter Lab, which gives you a little bit more, I guess, features than running flat out Jupyter Notebooks. What do I got next? Same thing, Jupyter Lab, but I wanted to show you the terminal interface to Jupyter Lab. And again, what I really am showing here in this screenshot is the exact same scientific computing environment that is available to my HPC command line users is directly accessible and directly usable to me within the sort of web delivered data science notebook environment. And then finally, the last set of screenshot is, it's Posit Workbench. I should probably show RStudio Professional. This is the RStudio Professional thing. And what I wanted to show you here again is, if you look at the highlight here, we have a choice of multiple versions of R. These versions of R are actually coming from our centrally installed scientific software suite. So again, the same version of R that I'm using in my data science notebook is the same version of R that's available for people who are doing reproducible science down on the command line, with batch scripts, that are going directly into Slurm. So the unification is one of the things that makes me kind of a fan of this solution. All right. That was a lot. That was a picture tour. Hopefully that sort of got you interested in sort of, what you can see when you do something like this. I'm basically going to dive in and spend the rest of the webinar really just talking about, some of the lessons that I learned doing this a couple of times in different environments for people who had different requirements. So the first thing you're going to have to do, and I talk a lot about decision-making and planning, is you need to find the best common denominator between, because at the end of the day, they're two different products. AWS ParallelCluster is different than Posit Workbench. So you have to start thinking about, what's the harmonious set of components that I can pick that will unify these all things together. So I've highlighted what they support at this time. For me, the sweet spot is Ubuntu. ParallelCluster doesn't support Ubuntu 22 yet, so my default is Ubuntu 20. One of the reasons why I like Ubuntu, and one of the reasons why I evangelize Ubuntu in enterprise and pharma, is that Red Hat Linux moves too slow for data science. The versions of glibc and the kernel versions are often not as modern as we would want. However, enterprise really likes Red Hat Enterprise Linux because it's very stable, it doesn't crash, and it has 7 years of patches. On the flip side, Amazon Linux, Fedora, some of these other Linux distributions, they take kind of the opposite approach. They might be very short-lived, but they're very bleeding edge, but they move very fast. But you don't get many years of security patching out of say Fedora, something like that. So what I'm really looking for, and what Ubuntu solves for me, is Ubuntu is modern enough that the kernel versions and glibc and the capabilities of the OS are sufficient for data science and people who need sort of more modern capabilities of Linux. But at the same time, if you stick to the LTS versions of Ubuntu, you also get 5 to 7 years of patching, security updates, and things like that. And so, and then the final thing is Ubuntu has one of the better sort of native graphical desktop environments if you need to run Linux on a laptop. So again, you see people who are running, parallel VMs on MacBooks. You're starting to see that Ubuntu is becoming fairly pervasive because it's the system where people are developing these applications on. It's the system where people are running desktops, virtual Linux desktops on their laptops. And then finally, I use it in my scientific computing environment because it gets me the modern features that I need in a package that makes InfoSec and IT ops happy, because they'll at least get a couple of years of patching and security updates out of it. Moving on, besides, that was a long-winded way of saying pick a Linux flavor and pick one that you can run consistently across this environment. The second thing that you need to think about beforehand is this is probably the single biggest mistake my startup customers and my stealth mode biotechs make is you really do not want to create multiple islands of identity. And it's a very common mistake when you first get into scientific computing on Amazon to start creating IAM users or building up an LDAP server or creating kind of a disconnected island of identity. You want to avoid that at all costs. It really breaks as your company scales over time. And so what you really should be thinking about is what's the lowest common denominator of sort of centralized password checking and user resolution that I can get out of the environment. There's really no wrong way to do this. The technical goal is you just need to have a consistent view of Linux users on the Posit machines and the ParallelCluster machines. I've seen everything from local user accounts that are kept in sync via Chef, Puppet, or Ansible, all the way up through some very special people who are doing really cool things with privileged access management tools like Okta Advanced Server Access. So there's no wrong or right way to do it. At the end of the day, the technical requirement or the business requirement is a consistent view of UIDs and GIDs and a consistent way of authenticating via SSH key or password to this environment. My default recommendation is LDAP against Active Directory, and I'll spend a little bit talking about why. So I've already talked about wanting multiple islands of identity is bad. LDAP against Active Directory is solid. It's been very solid in Linux, particularly the SSSD subsystem, for a while now. It's also natively supported by ParallelCluster. So for instance, if you feed ParallelCluster the right LDAP configuration files, ParallelCluster will spin up, and from day one, your first login, you're logging in with your Active Directory credentials. And then finally, I don't like joining my auto-scaling systems to an Active Directory domain. It's really easy to script the realm join. It's relatively difficult to script the unjoin, when you're destroying a server or scaling out. And if you don't get serious about managing your domain joined machines, what you end up doing is polluting your Active Directory server with thousands of zombie entries for nodes that might have lived only for an hour or two. So I don't like binding directly to Active Directory for that reason, because auto-scaling plays havoc with with that type of approach. So for me, LDAP is the kind of lightweight, scalable, and it makes InfoSec and IT and even HR happy, because if someone separates from the organization and they're terminated in AD, their password stops working right away. So it solves a lot of secondary operational and security questions. When it comes to specific advice about doing this, there are ways around this, but if you follow the ParallelCluster guidance involving AWS Managed Directory, it's relatively hard to trust the certificate that AWS uses for their managed directory service. And their guidance is basically set up a load balancer between you and managed AD and have the load balancer terminate SSL before it spits LDAP back to your servers. That's just extra work for me. I don't really feel like terminating SSL. So what I'd like to see is, if possible, I'd like to see either a real domain controller. It doesn't matter where that lives. It could be on-premise, it could be living in a co-location cage, or it could be in AWS, but a real domain controller I can talk encrypted LDAP to, and I can get the certificate and I can trust the certificate. And then finally, that last point is really important. The most practical hybrid cloud design pattern that I've seen for scientific computing basically boils down to identity lives in Azure, scientific computing lives in AWS. And so I want to be explicit that Azure Active Directory as an LDAP source for this type of environment actually works really nice. And it's probably the most popular design pattern that I see is teaching ParallelCluster and teaching my Linux servers to talk to Azure AD as their, LDAP source of truth. So finally, moving on to the next decision you have to make. So decision 1 is pick your Linux. Decision 2 is figure out how you're going to achieve that unified view of Linux identity management. And then decision number 3 is you are going to want some sort of persistent storage layer, and it's going to be a POSIX storage layer that presents files and folders because we need home directories and we need configuration files and things like that. There's a couple of different ways you can do this in ParallelCluster. You can use a volume-based approach, in which case you basically provision a disk volume of arbitrary size, you attach it to the ParallelCluster head node, and then the ParallelCluster head node, when it recognizes it, will automatically turn around and re-export that volume out via NFS. So you can get to a shared file system via this hack of attaching a volume to the head node and re-exporting that volume out. That actually works fine. There are scaling and bottleneck issues, and sometimes you might have to over provision the head node, if you're using it as an NFS file server. But your second option is instead of using a shared volume approach, you can actually use a full-on managed shared file system service. And so AWS's family of managed file shares is growing all the time. The two most common in this world and the two sort of most natively supported within ParallelCluster are AWS EFS and FSX for Lustre. EFS is basically, if you're not familiar with it, it's their managed NFS v4. So at the end of the day, if you see EFS, just substitute NFS. It's a managed NFS file share. FSX for Lustre is the same thing, except it's a managed Lustre parallel file system environment. And in this model, there's no re-exporting of an NFS server. There's no re-exporting of a volume. The cool thing about EFS and FSX for Lustre is all of the systems in this platform that we're talking about today just directly mount that file storage directly, at either an NFS mount or a Lustre mount. So some tips here, lessons learned is never let ParallelCluster create and manage the shared storage for you. The reason why is a lot of guidance around, HPC on the cloud sort of implicitly assumes that you're going to tear down everything to nothing when you're done and you're just going to leave a smoking crater or you're going to leave nothing behind. That's not true in my world. I want a storage system and a storage layer that is long-lived and is managed independently of my HPC clusters, because I create and destroy HPC clusters all the time. I add and remove clusters, I change them, I upgrade. What I actually want is I want a persistent storage layer that I can attach, detach, and sort of, graph on different HPC and computing environments to that long-lived storage layer. If ParallelCluster is in charge of that storage layer is going to get destroyed when you destroy the cluster. So tip number 1 is always create your external storage resources independently of your HPC environment, because it's far more likely your storage is going to live for a long time and your compute environments are going to come and go. The second thing is shared volumes are fine. They actually work great at team scale, but just recognize that if you're attaching an EBS volume or a ZFS volume to the head node and re-exporting it via NFS, there are going to be throughput and performance considerations that you have to work through. But there are also likely many people and many teams who will never need anything beyond that. And so if you're going for low cost, the volume-based method is perfectly fine as well. So the other thing to think about here, and again, I have to call out Posit for the quality of their documentation. There are some edge cases around EFS that you should be aware of. In particular, EFS is technically NFS v4, but they don't support all of the NFS v4 options, including ACLs, which means that Posit Workbench project sharing features, which rely on ACLs, don't actually work in an EFS environment. There's some oddity involving file locking and synchronized sessions across nodes, but more importantly, they actually recognize that thing that many of us recognize is that EFS is not particularly great at small file operations, and they specifically call out that if you're an R or a Python person, there's a lot of packages where you might be dealing with directories of thousands of small files, and so you want to be a little bit cognizant of the potential for EFS to be a small file I/O bottleneck if you're doing a lot of things with big packages or directories that contain lots and lots of tiny files. That final bullet point, though, is I really don't want to scare people away from EFS. Like if you look at this slide, it's like, oh my gosh, stay away, we have to do something else. EFS is my absolute go-to standard for POSIX storage on a scientific computing environment. It's my starting point. I go to something else. I go to something different. I go to something faster, only if business user or scientific requirements take me there. So it is totally okay to start out with EFS. It's actually okay to mix and match EFS and FSX. I don't quite have the technical details on how many I can mix and match in a parallel cluster, but with DevOps and configuration management, if you needed to have an FSX share for performant workloads, and an EFS share just to hold software and config files, it's not particularly hard to wedge into your mix. I was going to say more often than not because of EFS small file IO issues, and also because I'm sort of interested in some of the capabilities of FSX involving automatic data repository associations and being able to sync data in and out of S3 buckets or prefixes within an S3 bucket. More often than not, when I build an environment like we're talking about today, my storage layer is FSX Lustre. It's kind of my starting point. It's not super expensive to run Lustre at small scale. I don't stash petabytes there. I've talked a little bit about the reasons why I like it. I like the S3 integration features that the persistent 2 version of Lustre has. I actually get some wins with the LZ4 compression that's native. A number of life science data types actually compress fairly well for those that don't sort of use binary data by default. And then finally, this is kind of evil or cynical of me. I like the idea of deploying a Lustre system that is small but fast, and using it as a way to nudge users into using different methods of accessing storage. If I artificially constrain my Lustre storage to something small, it basically forces the users to think a little bit more about how they want to handle data, how they want to move data, how they want to stage data. And for me, that's the carrot and stick approach that I use to kind of nudge them into, don't stick your petabytes of data on my Lustre file system. Stick your petabytes of cryo-EM data or imaging data or genomic data, stick that in S3 and, and learn to code and learn to work with sort of native object storage patterns. So I also like Lustre and putting an artificial constraint on things because it helps me nudge my end user community into the future object storage world, where I am of the camp that believes that the future of scientific data at rest is almost invariably going to involve an object store. The era of POSIX and files and folders is kind of on its way out. So the next thing you have to think about is your approach to automation and your toleration for automation. If you look at what ParallelCluster does, ParallelCluster emits a CloudFormation stack. So if you wanted sort of parity with what ParallelCluster is doing, CloudFormation is kind of a good starting point. I would say that, some level of automation is desirable, but the nature and complexity of the automation that you choose to deploy is going to be up to you. And the reason why I'm going to stress this is that it is definitely possible for over-enthusiastic teams or architects to over-design your automation to the point where you spend more time developing your automation than you do actually deploying solutions. So you have to find a balance between how complicated and hardcore your automation is and your DevOps versus at the end of the day, you just want to deliver systems to scientists to get cool work done. So there's 2 focus areas in this, and I break it up into the infrastructure that supports this environment, followed by the methods and tooling that I use to configure servers, and basically automation to build and deploy AWS resources, and a second set of automation that handles all of the sort of fiddly configuration bits inside a running server. And so I break that up into 2 areas. So there's no one size fits all. I've already talked about this. There are some groups that want to have, fully DevOps enabled CI/CD end-to-end automation from start to finish, but they know they're going to be running in a single Amazon account and a single regionalized VPC. So they don't have to think fancy about multi-account, multi-environment, multi-region deployment. There's going to be another group, probably a global enterprise pharma, that needs end-to-end automation using a completely templated environment with no dependencies that are regional or zonal, so that you can literally press a button and deploy this environment in any Amazon account, any environment. When I say environment, I'm talking, dev, test, QA, and prod, and finally in any global region. And then again, like I've said here, over-engineering is a risk here. You don't necessarily need to build your automation to handle any Amazon account, any environment, in any global region if you're never going to run scientific computing workloads anywhere other than US East 1 or US West 2. And then finally, again, being honest, it is not possible to achieve 100% end-to-end automation in a lot of environments, because a lot of our environments still have processes that are human bound or require a ServiceNow account or require change management. The cliche ones for me are DNS records and SSL certificate or PKI provisioning. So for instance, there's a lot of environments where DNS is managed out of Active Directory, and to make a DNS record, you have to create a help desk ticket. That's not going to be automated, because you're not using Route 53 or API-driven DNS records. Same thing with PKI provisioning and certificates. Yeah, many of us can do stuff with Let's Encrypt, but others, we work in organizations where there's a dedicated PKI team. They run their own certificate authorities, and you have to send CSR requests to them via a ServiceNow ticket, and their SLA is 24 hours to get the certificate back to you. So again, not automation friendly. You've got to recognize it. You've got to work it into your process. And then finally, the last example is I have some customers that flat out block unrestricted outbound access to the internet. That can break POSIT license checking. So again, sometimes you might have to do an offline license validation. The upside is POSIT has very cool tools for handling license scenarios when you're not allowed to talk to the internet. But again, this is an example of things that could kind of break. And it's really easy to talk about the nirvana of end-to-end fully automated everything. Realistically, when you're down in the weeds in a legacy or an enterprise IT environment, you're going to hit the real world stuff. You're going to hit the fact that you can't automatically provision an SSL certificate, or you can't instantly create a DNS record. And you just got to live with it. You just got to build it into your process. I've already talked about this stuff. I think, when you're looking for general guidance, if you don't need to engineer for multi-account, multi-region, I like using Terraform or CloudFormation to kind of create the enabling resources. And I like using, standard configuration management tools like Ansible, Puppet, or Chef to handle, the kind of, creating configuration files, installing software, installing packages, things like that. What I want to specifically call out on this slide is that it's okay to build dependencies into your automation that are specific to the environment, zone, or region that you're running in. You can hard code subnet IDs, VPC IDs, FSX file system IDs, because you don't have to parameterize this. You don't have to abstract it to handle multi-account, multi-region, multi-environment. So don't feel guilty about putting hard-coded dependencies or values into your plans if you're sort of in this state. If you're in the community that needs to, I'm trying to think, I might have hit this. So same thing. If you need to go hardcore and support any account, any environment, any region, at the end of the day, your automation just has to be templated. So there's no hard-coded things. And you also have to enable automated discovery so that your Chef or your Puppet or your Ansible code can sort of discover the breadcrumbs it needs to set the host name properly for the zone or the region that it's in. It's a lot more complicated to get to this environment, which is why I'm sort of throwing caution at you is, only do this end-to-end automated, fully templated deployment with auto discovery if you know that you're going to need it. Otherwise, you're just throwing a lot of time and a lot of resources at a really cool solution that you're probably never going to use. So we've talked about, so this was kind of the automation approach. And I think to summarize that is basically figure out your tolerance for automation, figure out the amount of resources that you want to invest, probably figure out if you're going to be doing Terraform, Ansible, or CDK, kind of pick your environment there. But then you have to have the same conversation about your tooling. What are the methods that you're going to use and sort of scoping that out. And so, if I need to mention this out here, so for infrastructure and code, most commonly I see CloudFormation and Terraform. I know I'm in a serious environment when I see people writing TypeScript or developing natively in the CDK. I'm a crap programmer. I could do Python, I could do Ansible, I could do CloudFormation, I could do Terraform. I do not know JavaScript. I do not know TypeScript. It's unlikely I'm ever going to touch the Amazon CDK. I'm impressed when I get to work with people who live and breathe that stuff. But these are kind of the common platforms that we typically see in our world. The final thing you have to think about is what else. And the what else for me is what else do you want to have in this environment besides ParallelCluster and besides RStudio Workbench or Posit Workbench. For me, that's VDI. For me, I like to have a cheap D2 microserver that I'm using as a ParallelCluster deployment or management tool. So when you're planning, just think about what other things you might want to graft into this environment. And so that's basically it on the sort of decisions and things you want to think about. So now I need to disclose my bias because I want to show you a little bit about the way that I work and the way that I do things. So I tend to use CloudFormation or Terraform. I choose CloudFormation or Terraform based on what's best for my customer. What is their standard? Are they coming into cloud maturity and just kind of learning things, or are they sort of already all in on CI/CD and they're running Terraform out of Azure repos? And then finally, for configuration management, I've sort of fallen in love with this Ansible Git pull method, and I'll talk to you a little bit about that. This is, again, just a little bit of a picture tour. Terraform, I really like it because I can apply really cool things like consistent tagging across all my infrastructure. This is an example of an FSX Lustre defined file system. This is the two different databases I need to deploy. One is Slurm accounting data. One is RStudio metadata database. And then finally, for auto discovery, I like to create a lot of SSM parameters. So my Ansible scripts can query SSM and sort of auto discover things like file system IDs and host names and what domain name they should use in this particular account or region. And so that's kind of my Terraform bit. Now I want to talk a little bit about, Ansible. This method was sort of recommended to me by Carl and Adam. It uses a pull-based model instead of push. Basically, my preferred method is I like to use Ansible to pull a playbook out of a code commit repo. And the reason why I like it is that it's pull, code commit. The authentication is really easy with IAM and EC2 instance roles. I don't have to worry about secrets and keys and credentials. And so this also delivers to me a universal bootstrap method that is going to be consistent across my environment. I'm running out of time a little bit, but I wanted to kind of harp on this kind of universal bootstrapping environment. This is literally the code that I use. And this is the same code that I would use in an user metadata when I launch an EC2 server, but this is also the same script that I run as a custom bootstrap action within ParallelCluster. So my universal bootstrapping script works via user data or ParallelCluster, and at the end of the day, it installs a couple of packages. It sets up a cross-account profile so that I can pull Ansible repos from different areas if I need to. And then the final thing it does is it pulls down the playbook, it executes it directly, and it brings my node into whatever state I want it to be. I'm a big fan of this approach. I don't want to evangelize it. It works for me. It may not work for you. Everybody has their own different way of doing this, but my slides and content is kind of specific to this working style. So I've already talked about this. In ParallelCluster, I do it as an on-node start custom action. On Posit server nodes, this is just a user data script that we inject into the environment when we provision it. Pausing here, because I think, again, we're getting low on time. Before we talk about the specifics of integration, this is kind of the things that you want to cover. Basically, it boils down to Linux distro, identity management, what your storage is going to look like, and what your automation tolerance and tools are going to be. Again, dropping you back into the sort of realistic diagram here. This is kind of a faked nature of what I would typically deploy in the absence of any actual data. And so finally, getting down into the weeds here, the things that you have to think about here. Configuring ParallelCluster to be aware of Workbench is relatively easy. At the end of the day, there's only a couple of steps. You need a consistent view of R in Python. There's a particular set of RStudio session files that need to be present on every node. You want to have Jupyter kernel configuration files present on every node. And then finally, it's helpful to copy a couple of files out of ParallelCluster that Workbench is going to find useful when it self-configures. I've already talked about this here. I'm going to skip over this slide except to say that there are certain things, particularly the R session package that needs to be put on every node that if you do it the wrong way, is going to slow down your deployment. I've definitely broken my deployments or added 12 minutes to the wall clock time when I've done it wrong. For time reason, I won't go into this, but you need to be careful about how you sort of push this stuff out. I've already talked about this, kernels. I've already talked about useful files. What I will say here is from a configuration perspective, there's a couple of different things on the ParallelCluster environment that if you can shift them over to Posit Workbench are going to be helpful for you. The big one is the Munge key so that your authentication is consistent. Slurm uses Munge for authentication. And then finally, the Slurm profiles that set up paths and environment variables. You drop those on your Posit Workbench node and you're kind of ready to act as a Slurm submit node. It's a little bit harder and a little bit more complex to make Posit Workbench aware of ParallelCluster and get that integration going. And I don't have time to kind of go through every single Ansible playbook, but at the end of the day, you're looking at the key tasks here. It's basically, build kernel support for your storage if you need to, make sure your FS tab mounts all of the storage that you need on reboot. You want to actually mount the NFS shares that are coming off of the ParallelCluster head node. And then at the end of the day, there's really just two things that you need to do. You're configuring Workbench to be a Slurm submit node. And then you're configuring a bunch of Slurm specific things in Posit Workbench, which is launcher files, profiles, resource files, and things like that. And then finally, if you want to be hardcore and automate end to end, you generally are able to programmatically generate the configuration files on the fly using templates and values from Parameter Store. That's kind of hardcore, but you can get to a point where even all of your Posit Workbench configuration files are programmatically generated when you press the deploy button. Again, for time reasons, authentication, this is just kind of the checklist. ParallelCluster will come with the authentication out of the box if you turn on LDAP. If you want to get it going on your Posit Workbench server, there's a list of sort of things that you need to do. Same thing, hostname is really cheesy, but if you want to support HTTPS and encryption for people pointing their web browsers, you got to make sure you have a nice, ready to go, fully qualified domain name and DNS entry. Storage clients, again, you might have to do some sysadmin work or some kernel work if you need to build EFS utils or get the kernel, basically the kernel specific versions of the Lustre client going on the RStudio server so you can mount the Lustre file system. Head node NFS, I've already talked about this. If you want access to Slurm and the binaries in the Slurm commands, you need to NFS mount a couple of directories that are coming off of the ParallelCluster head node. You could do really neat auto discovery things here if you simply publish the IP address of your head node as an SSM parameter store value or something like that. FS tab, again, you want this thing to be able to reboot. You want it to be able to come up with all of the storage systems that we previously just talked about. You should probably test this a couple of times before you hand this over to your users. And then finally, Slurm submit host. I don't have the time to kind of go into this specifically, but it looks complicated. But at the end of the day, making sure your Munge user UID and GID is consistent, making sure the Munge service is running, and making sure that the Munge key is consistent between environments. If you do that, your Munge commands and your authentication to Slurm and Posit Workbench will actually behave as a really nice, Slurm submit host. Installing Workbench is very easy. It's actually harder to install the configuration files and to install the package. Again, this is kudos to the Posit people. They make their software really easy to install. And then the last and final step here is I do really want to talk about, I could talk at length about this, but I'm torn on whether I programmatically generate all of my configuration files on the fly. I really do think ownership of Workbench configuration files really needs to belong to the application owner and not IT or the DevOps or the cloud team. So I'm starting to favor an approach where I leave maybe stub files or example configuration files that I generate that have all of the information they need, like the RDS database path name and the database username and the credentials, but I don't want to own the configuration files and I don't want them versioned out of my Terraform repo. I want them to be owned by the person who's going to be supporting the system. So there's some interesting conversation to be having about how you generate the config files and who owns them. I'm definitely in the camp that the DevOps team that's deploying this stuff should not own the Posit config files. That needs to be closer to the users, closer to the data scientists, closer to the support staff. These are all of the essential files that I touch. If you did want to programmatically generate config files, these are all of the config files that you would programmatically generate and push down to your RStudio server. And that's it. I think I'm probably fairly close to running out of time. I think, Adam, maybe we'll have to collect questions and maybe follow up over email. But at the end of the day, this is kind of the take-home message. This is not rocket science. You don't need BioTeam or a fancy consulting to do this. The quality of the Posit documentation is fantastic. Their support is fast and responsive. They've got professional services and TAMs and account managers who can kind of help you get up and running. So at the end of the day, the biggest hassle into kind of getting to this environment is really just making the Posit servers share the same view of identity, getting Munge to work, getting the Slurm bits to work. After that, it's really just configuration minutia, which is a learning curve, but not a big deal. So again, this is not fancy. This is not exotic. You don't need fancy consultants to do this. You can totally do this on your own. And that's really kind of the message that I want to sort of push out there. And then finally, all right, that's it. I think I did finish technically before the end of the hour, but yeah, sorry, Adam, that was about 92 slides in 54 minutes.
That was excellent, Chris. Yeah, that was great. Thank you for that. In a couple questions that came in, you actually answered them live. One of them was just about, whether or not the Posit Workbench is on its separate EC2 instance that stands alone outside of ParallelCluster. I think the answer is yes, right? That's sitting on a standalone node, right?
Yeah, that's correct. There are design patterns that will put Workbench on the ParallelCluster head node. I like to keep them separate. Like I would have a separate Connect server, a separate package manager server, and a separate inexpensive Workbench server.
Yep. Another quick question. Have you seen, sort of multiple POSIX storage being used? So for example, EFS just for the home directories and then FSX for a working directory or a scratch or something?
Yeah, for sure. And actually, that's probably the effective way to do it. You can use EFS for home. You can use EFS for your centrally managed software that's managed under environment modules. And maybe you have a very small FSX Lustre system, the 1.2 terabyte minimum. And maybe that's just your active tier or your scratch tier. And you sort of intentionally go out and do it. That is a very common design pattern, and it would be common to have different flavors of POSIX storage in an environment like this for exactly those reasons. Scratch versus, home directories and scientific software.
Awesome. And last one, for automation, do you also look to tools like Easy Build or SPAC for application installs? And I could take the part of that. We definitely like Ansible and Chef. I also like that, ParallelCluster uses Chef internally. So if you already like Chef, there's a way to kind of override the ParallelCluster cookbooks. But yeah, go ahead, Chris. Do you ever see SPAC or Easy Build or other tools?
Yeah, and I was going to say, you can tell my age because I talk about environment modules. All of the younger early career cool kids, they're all using SPAC and Easy Build. I've seen all of those. I really like them. SPAC and Easy Build in particular are great for reproducibly being able to build and install scientific applications in a great way. And the other thing that's in my slide, but I didn't really mention, is that I have another couple of customers who don't like this live configuration management with Ansible and Chef. They're really comfortable with Packer. And they will actually just generate custom AMI images with all of the configuration baked in via Packer. And so all they have to do is literally launch an AMI image and everything comes up. So yeah, I've seen all, and that's one of the reasons why I didn't want to push my particular views on this audience, is that there's so many different ways to get to the same solution. The best DevOps and the best automation tool is the one that you use internally and the one that your people know how to use. Don't listen to an outsider tell you, to use Terraform or CloudFormation. Use what you know how to use and what you have resources for in-house.
All right, and last minute, we have one last question. How do you interact between data located in S3 and EFS or FSX file systems?
Yep. So that's a good point. When possible, so for instance, a lot of the data science notebooks, like if you're writing in R and Python, there's a lot of libraries and modules that are S3 aware. So wherever possible, I will try to keep my data directly in S3 and compute against it directly in S3. However, there are a number of use cases that require that data to be brought out of S3 and stored on a POSIX files and folder system. So I've done everything from rsync, I've done Slurm epilogues and prologues that will stage data in, run my job, put the results into S3 and then delete the data that's staged out. And then finally, this is one of the reasons why I like Lustre, is if you dig into Lustre that AWS has done with their automatic data repository associations, there are interesting ways to automatically flush the contents of an S3 bucket into your Lustre file system so that you can compute against it. And there's even ways to flush the changes back into S3, but at no point in time is the Lustre version, the canonical version of the data store. Like, your source of truth is always in S3. So basically my methods are, I will natively use S3 with possible. When not possible, I will do anything and everything to stage the data into a POSIX file system so I can compute against it locally. And then finally, I'm really enthusiastic about the state of Lustre and the ADR associations with sort of buckets and prefixes, because I think there's some cool lessons to be learned in design patterns about automatically staging in from S3 and automatically flushing the changes out and maybe hiding some of that complexity from the end users. So maybe the end user just sees that, the files in Lustre, they don't necessarily care that it's coming in from an S3 ADR and being flushed back out to an S3 ADR.
Fantastic. All right, well, we're out of time. Again, thanks everyone. Thanks, Chris.
Thank you, everybody. I really appreciate your attention. And please feel free to send feedback and let us know what you'd like to hear us talk about later. Thanks again.